Hey everyone, and welcome to the Bash tutorial. I am Max, and thank you for coming to this one instead of the regex tutorial first. That means that you're the cool kids, and that those other losers who went to the regex one, well, they'll know. They'll know. Anyways, let's talk about Bash scripting today. Here's the Purdue tutorial that you get. We're going to look at this as well as some bash scripts I made to show you a little bit more in depth. So let's look at this very simple hello world. In fact, let's zoom in a little bit. Make life easier. So first line, real simple. It is a comment, technically, but this is a special comment because what it's doing is it's telling our operating system what shell we should be using. So it's going to be the location of the interpreter, in this case bash. It's just going to start with that this pound sign, which is normally a comment. In this case, it's kind of a special comment. And then exclamation mark, and then we have this, almost always at the very top of our file. Another comment, again, it's just going to pass over this. Now we make a variable. Now, this is an environmental variable. There are certain things about it. First of all, it's generally convention to write it all caps. You don't have to. I don't, but depending, unless it's certain circumstances, but you can. Notice there's no white space around this equals or anything, and that's because white space is kind of finicky in this language. It's you need to be careful with it or it's just not going to work. So, and the thing with bash is it'll just fail silently a lot of the times. It's happy to just stop working and not tell you why it's not working, and then that's it. Which can be infuriating, but it can also be good at times, I guess, maybe. Things don't crash. So, finally we have echo command. I'm sure you've seen this at some point. This is just going to print out a string. In this case, we use this $sign. Whenever you are accessing one of these, and you're not doing like an initialized assignment thing up here. Whenever you're accessing one, you're going to need this $sign. So, just so you know. And what this is going to do is this entire thing's just going to print hello world, obviously. Not too bad. This just goes over what I just said there. We can also do if statements. If statements are pretty weird. Technically, they take a command. You say if, and then you write a command, and then that command is going to be returning some value interpreted as true or false. However, sometimes it's not really a clear command. In this case, we just say -d and then whatever our input is, in this case a directory. What this is doing is checking to see if a directory exists. What's really going on here is whenever we have this, it, in so many words, means we're basically calling a command called test. It's just kind of a shorthand for that, and that's going to see if something's correct. Shut up, Windows. I hate it. But if you ever see these around, it's calling the test command. And if you're doing one of these comparators where we're just doing a dash something, it's probably needs these around them. Notice that we then have semicolon, and then the word then. A lot of people write it this way. I actually, in most of mine, will just get rid of the semicolon, not have a space, and then just do a new line and have then down here. And that's fine too. That works as well. but you can do this if you want. Again, just be careful of white space. You can't be forgetting this space, you can't be forgetting this space, you can't be forgetting this space. If you do that, it's just not going to work. It's going to break, and then you'll be like, why isn't my if statement working? Well, because bash is a pain. In this case, if the directory exists, we say so, else we do not. And finally, we end this entire structure by saying phi, just if backwards. We can also use pipes. Pipes take the input from one program and bring it to, or the output from one program and feed it in as the input to the next, which is really cool because we can chain all sorts of programs together in really neat ways. In this case, we're going to learn about the user by first using who, which is going to get us the user information, and then we're going to grep for of everyone on the machine, and we're going to grep for the user's name. Grep, by the way, it's basically a search function. It can search through a file usually. In this case, we're not using a file. Instead, our input is coming from the pipe. But it searches the file for whatever this pattern is. Now, we'll talk a lot more about those patterns. That's regex. That'll be in the regex tutorial. But here we just have this user. It's going to end up going down to be a string. And a pattern can totally just be a string. That's fine. If it's just a specific thing you're looking for, that works. So in this case, the entire program, all it says is, it says that it's going to look up data about the user, and then it does. It looks through information about all the users and looks for ones that involve that user. Lines specifically. It'll print specific lines. We can pass multiple arguments. So this $1, 2, and 3, these are the arguments that you give to your file. So if this file is passing arguments.sh, and you passed it 3 strings, then those strings would be stored in this $1, $2, and $3. When we get into functions, those will start to act a little differently in certain cases, but normally these are just going to act like special variables that are holding our arguments. File I/O. Okay, so these are very important. We can redirect file I/O in all sorts of interesting ways. We can take the output of our program and send it to a file. If we have 2 of these instead of 1, so if we have greater than instead of just 1 greater than, then it appends to the file. There's a whole list of different specific I/O handlers you can use. The other interesting one, though, is we can go the other way. If we have this less than symbol, we can say our out file is going to be the input to this. So we can take output from a program and send it to a file, and we can take input from a file and send it to a program. Now, it's important to know the distinction between these and the pipes. The pipes are working between programs, between processes. The file I/O redirectors are working between programs and files. So, important distinction. Here's a mailing example. You'll need to use this at some point. The important thing is, here's a command, user/bin/mailx. You can set a subject, you can tell who it's going to, and that's it. Very simple. You'll need to set up some stuff for that, obviously, up here, but by putting it into this file and then using that file to actually send the message. But I would probably mainly just look at this when you get to your part of your program where you need it. Loops. Okay, there's a lot of ways to do loops, actually. A weird number of ways to do loops in Bash. The 2 obvious ones, though, are a for loop, and actually a for each loop, for one of them, for this one even. For f in subshell. We'll talk about subshells at some point in this. ls var, so we're getting all the file names var. We're going to print them. So it'll go through and print each one. We can also do while loops. In this case, we have a count, and we're going to keep looping while the count is greater than 0. Again, you can see these square brackets, which mean we're using the test command. And inside, we are both iterating upon that integer, and we're using echo to say what's going on. Now, this let command we're going to talk about in a little bit, but for right now, let's just understand that it is being used to increment these variables, specifically integers. It is only good for integers, but that's all we need it for right now. String manipulation, you can concatenate them, that's all you really need to do with them, mostly. Yeah, that's string manipulation. You can put them together, you can, I guess, take them apart in weird ways, you know. It's not super in-depth there. If you want anything super in-depth with Bash, you need to be using a specific program that Bash is calling, which is the beauty of Bash, and also the annoyance of Bash. We have some special environmental variables here. We can home, path, and user. These are all going to be implemented on all of your systems, so if you do $user, all caps, you'll probably get your login name. There's other ones too, which we'll talk about in a minute. And what does this one do? This is... Yeah, so this is using let again, and it's also... what does this script do? Oh, is it just counting? Weird. Yeah, it's just counting. Okay, that's fine. So yeah, this is a useful little one. You can find this on your on the actual page for the project. But what I'd like to talk about for the rest of the time are these. So we have this little bunch of files here. We're going to start with arithmetic, because that can trip people up. So data types in Bash are, I mean, you can definitely divide them up into different things, and we will a little bit later, but in reality, what's going on is everything's a string. Everything's a string. In fact, a variable definition here is just a name that is mapped to a string, basically. So we want to do some arithmetic. We want to do some adding, subtracting, dividing, multiplying. And we're going to start with just doing that with integers. We'll get to decimal stuff soon, but with just integers, there's actually a whole bunch of ways we can do it. That's kind of a recurring thing with Bash. There's a lot of ways you can do it, and not a lot of them are actually good. But, you know, you can do it. So one way is to use this expr command. We can, you see I have backticks here. Again, we'll talk about that soon, what a subshell is. But expr a plus b minus 5. So all of these, by the way, should end up being 30. It's the same equation, but using different means. So this should print 30, 30, 30. Here, same thing, a plus b minus 5, but this time we're using this let command. Notice again, no spaces in this. Just all the way through as one item. And then we can do this as a subshell thing, too. So if you use, but this is a kind of a weird subshell because we have double parentheses. So if you have $ parentheses, not double parentheses, it's something called a subshell. And in fact, it's the exact same thing as using these backticks. But I should really zoom in on this. Control-Shift equals, let's do that. There we go, that looks a little better. So anyways, we have these backticks, they work to make a subshell. Again, we'll talk about what that is. If you had just one parenthesis, that would make just a normal subshell as well. This is a special subshell though. in which we're doing arithmetic in. We're saying specifically we want to do arithmetic in here, or technically something called arithmetic expansion or something like that. And again, no spaces, just variable a plus variable b minus 5. And that'll do it. But there's a much better option in Bash, or at least one I like a lot more. And that is to take this let command, throw in some quotations, and then you don't have to do anything fancy with it. You can have all the white space you want in there. You can do things like plus equals. It's just really nice. I like it a lot. It looks. I think it looks the cleanest and makes the most sense. So in this case, let z equals x times 2 minus 3. Let z plus equals 11. So now we're adding 11 to z. It still has that number. And remember, when we echo this out, this is still a string. It's just when we're passing this to let, it's handling all the conversion and stuff. If you're thinking, wow, that seems slow if it has to actually convert every single time, yes, it is. Anyways, z equals z divided by 8, z equals z to the power of 3, and we're done. We can print that out. You'll also see when we run this that when you divide z, it's doing integer division. Let is only going to work with integers. So what do we do if we don't want to just work with integers? Well, one way is to take this string here, echo it, and pipe that into BC. That's basic calculator. It is worth noting, though, that basic calculator doesn't do floating point. It does fixed point. So you have to pass it a scale, and that scale is going to be the number of decimals it'll show. So in this case, we passed it scale equals 4, so 4 decimal places. All right, makes sense. Alternatively, if we want it to be presented in a more specific way, we can still pass it to BC, but then we can pass the results from BC to awk. Awk is a super powerful tool. We are going to just barely scratch the surface of it. It's its own programming language. We're just going to be using it for some basic stuff. And in this case, we're going to be using it to print out our decimal in as many spaces as we want from there. You'll be able to see the difference in that. Or my favorite option, I'm not actually sure you can use this in your labs, in this class anyways, in CS252. But, you know, I like it a lot, because it's just give it to Python. Why not? There's no reason you can't do something like this in Bash. Like, you can just give it to other languages and be like, all right, well, I need to use Bash, so I'm just going to use Python instead. Again, I don't know if that's going to fly for your labs, but, you know, in this case, I just took a bunch of Python code, wrote it out, made it so it works on one line with semicolons. You can use semicolons in Python. And then did that, and that's actual floating point, because Python does floating point. And again, I put it in this subshell. Let's talk about the subshell real quick. So the subshell is basically taking whatever shell you're running, in this case Bash, starting a whole new instance of it, running your program through that, and then closing that again, and just using it as kind of a one-off command inside a fresh version of the shell. And that can be really good for a lot of things, specifically if you want to say, let's say I have two programs, program A and program B. I have this variable x, and I would like, actually we don't even need to have two programs. Let's say we have this variable x we want, and we want to take that and put the results from a program into it. So we want the program to output something, and instead of redirecting it to a file or anything like that, we want to actually just put it into a variable. We can just do a subshell. put our program in the subshell, run it with whatever things we want in it, and it'll do it. It'll just run it in there, run it in the subshell, and basically copy and paste over the string that was output from that, and just put it right here. And that's a really useful tool, because you can't do this. It just doesn't work in Bash. But if you use subshell, you can do it like that, and it is helpful. And that is a case of that in the Python case. We're starting up a Python instance and letting it do its thing, letting it make all its computations, let it print out that, you see, this is not a special print statement, this is just a normal print statement. And then that just gets slotted in here, where our subshell is. That's the same thing with this, except in this case we are using the expr command. And again, to be clear, backticks, same deal as the $ parentheses. Not exactly the same deal as $ double parentheses, but similar. So let's run that and see if it does what we think it does. And yeah, so these first ones we get 30, 30, 30. Second one we get 5, 12. When we divide by 10, integer division, we get 51. That is very small, but I don't want to try to figure out how to get Putty to zoom in on that. Trust me, that's 51. Here we have 11.6666. That's our 4 floating points. We can have awk rounded up for us, or put more precision on it anyways. In this case, by the way, I just set the scale really high and then let awk trim it down as it would, including this nice little rounding thing. And then the Python version, which is my favorite. So, arithmetic's good. How about conditionals? So, if statements, that sort of thing. In this case, I'm going to make some variables first. I'll take, and if there's all sorts of like conditional expressions you can do, specifically inside of that test characters. I'll put this in the description if I remember to. That goes over all of them. Honestly, if you just Google bash conditionals, you'll find that too. But I'll try to put it in the description if I remember. So you can do a lot of the stuff you could do in C. In this case, string var equals hello. Then we'll print hello world. If it doesn't equal hello, we can print goodbye world. So that's good. These are for string comparisons, by the way. We can use greater than if we're doing comparing numbers. In this case, we have int var greater than 10, int var greater than 10, and int var less than 50, so we can say if it's between 10 and 50. Check if it's equal to 20, we can then see how we do an else statement. And again, like, you can totally do that, but I don't like it. I like doing that. That looks better to me. We can do elif. That's fun. So we can do kind of an else if thing. But if we're doing that, we have to have an other than clause, and then finally have an else. In this case, we're checking the directory. We saw that a little bit before. In this case, we have that file name var is lorem.txt. It's just lorem ipsum. We can use grep. This is important for your labs in CS252. So we can use grep to search for through the files, both for things like ipsum and foo that are just specific strings. Also, you'll probably want to use egrep, but extended grep, that's up to you though. And also for if we wanted this instead of ipsum to be some sort of wacky regex to search for something or other, that's fine too. It'll work with that. So that's if statements. They're not too bad in Bash. They're kind of blocky, but they do the job. Also note, we have this grep here. First of all, we have Q. That's saying grep isn't going to return a specific line, it's just going to have a return value if it found it or not. And that's 1 or 0, in which case we can use our if statements. And we don't have to use test. In this case, we just run this command. We don't have the test command in there, so we don't need these square brackets. Let's go to loops. So you can do a lot of things with loops. You could do, here's a for loop. Actually, completely forgot to run conditionals. There you go. It did the stuff. Yay. So let's go through for loops here. We have I. It's going to take these values as it goes. 1, 2, 3, 4, 5. Nice sequence. And you can see how something like that would be useful. For loops are useful. I don't think I need to have that argument. Like they're helpful for a lot of things, even if you're just going through different files and stuff. You can generate sequences on the fly with the sequence command. Again, we're using our subshell. This is going to do the same thing. In fact, I think all of these do the same thing except the last one. Do a while loop. Similar sort of thing here. We've $C is less than 6. We're using our test command again. And then we're going to use this let to increment C until it is no longer able to keep looping. And then lastly, we have this infinite loop that isn't actually an infinite loop, because while we're passing it 1 using test, we have a break in there, and then we can get out of it. So it's really just going to print this once. And let's take a look at that. What's it mad about? There we go. So yeah, it's going to count to 5 for each of those, and then it will screen one time. Let's go to files now. Files is kind of a weird one I have here, because there's not too much to talk about with files, I felt. So it's files plus some environment variable stuff. And even still, that's like the tiniest one, but whatever. So here we have an example of our output redirection. In this case, this program prints out hello world, and we redirect that output to this file. We can also do the same thing with append mode. So basically, in this mode, it's just going to write over everything and replace it with hello world. In this case, it's going to add this onto the file. So in our end file after this point, by line 10 here, should be hello world, how are you? Then we can cat that, see if it's actually that, and hint it is. This is word count. It's a really nice little utility. It can find number of words, number of characters, number of lines in a file. In this case, I have WC-W, which is saying actually do words, word count. So it's going to get this, and it should be 1, 2, 3, 4, 5. Looks good. Here's us linking programs together now, and you'll also see we used awk here again. And this is closer to the way you're probably going to end up using awk in a lot of ways. So to follow along with this, we start a subshell because we want to just pass this as a string to echo, and not like commands inside commands, you know. So we cat lorem.text. That means it's going to print out that file. Good stuff. We redirect that output over to tail -2. Tail -2 is going to cut the last 2 lines. It's going to keep them. Everything else is going to get cut. So it's going to just leave us with the last 2 lines of that original text. Then we send that over to awk, and we have this print $2 command inside awk. Now this $2 is not from here, or is not from bash. And in fact, you'll know that because if you do quotations like this, double quotes, and you $A, that will print whatever the value of A is. If you do single quotes and go $A, that will literally just print $A. In this case, we have those single quotes, so this is not a bash variable. This is in fact part of awk. And what it's saying here is to find the second word in each of these lines and print that. So we are going to have the last two lines of this, lorem.text, and we're going to get the last two words of it. So that's how you can string these programs together in interesting ways. And you could have much longer ones than this too. This is a pretty small example in some ways. And then we have all these interesting environment variables that bash comes with. Number of arguments that you've got passed. Here's the 0th argument. That'll just be the file name. Exit status of the last command. Process number of the current shell that you're running. Name of the shell. So let's take a look at that. Let's run files. And there we are. So we get this hello world, how are you? We find that it is 5 words long. The 2 words that we end up after still having after we pass it through this filter is ontcint. Doesn't mean it's from lorem ipsum, doesn't mean anything. And then we have all the outputs from these variables that are helpful. So last one for today, functions. Functions in bash are weird, and I kind of don't like them. But, you know, they can be helpful. And in fact, you're going to be glad to have them once we get to our process monitor, because skeleton code has a lot of them in there, and they make things a lot easier. So let's start off with this function, exit. Very simple. Or quit, it's just going to exit. It's just, you call this and it will do this. Perfect, that's fine. This one is a little different. It is going to print out these two. Now in a normal bash file, these are going to be the arguments to the script. However, if you have a function and you are inside of that function, then they are going to be overwritten by the arguments to that function. So, and we're going to see a little bit more of how that works. But otherwise, after that, we're just giving it this $1, and it's going to use that to print goodbye so many times. And hello is not much different, except that it's going to have goodbye at the end, and in fact, it's going to have another argument that we use to determine how many times it prints goodbye. But it's going to print hello first. We have this function returner. This is going to tell us a little more about returning in functions. And there's no proper returning in bash. The closest thing to it, and the way we're going to think of it, is using a subshell to catch output. You can in a lot of ways think about every function as its own little shell script, but it's also not. Don't think it's like its own process or anything. I don't think it is. Pretty sure it isn't. But in a lot of ways it's going to act like that, so we can treat it like its own little program, put it inside of this subshell, and get the output. So in this case, first thing we do, we call hello 5.2. Alright, well that's going to put 5 and 2 into our arguments. Go to hello. Should print 5 and 2 here. And then it should say hello 5 times. Send that to goodbye. Goodbye 2 times. And then it will be done. It'll go back here. At that point we can catch returner. Get that. This is a return value. Print that out, and then call the quit function we made. So that's functions. You can do all sorts of stuff with them. They're fairly there's not all that much to them, but they're very helpful for organizing your code. So let's functions. Let's run that. And that's about what we would expect. So we didn't pass any arguments, so 1 and 2 are empty. We did pass 5 and 2 into the hello function. So it's going to get argument 1 is 5, and argument 2 is 2. The goodbye function, we just passed it, just the 2 value, so its argument 1 is going to be 2, and it's not going to have an argument 2. And again, you can see how like bash will just silently fail. In this case, there is no in this case, in all these cases, there's no argument 2, except for this one. And if it can't find it, it'll just say, all right, I guess it's an empty string. That's just how bash does things. And that's basically it for our bash tutorial. So go check out the regex tutorial. And yeah, that's it. Peace.